This is part 5 of my homemade CNC router build, and in this video it's finally time to cut some parts. But first I had to go through and make sure everything was aligned and square, which the cutting bed definitely wasn't. It wasn't only out of being flat, but it also wasn't square with the frame, and therefore the x-axis, which I think is caused by these countersunk bolts that don't allow for any adjustments when tightened down. So I removed it from the machine and used a counterbore end mill to add counterbores to the holes. This will allow socket head bolts to be used, which can be adjusted when tightened down. And I was able to get it 0.037 out of level on the x-axis and 0.032 out on the y-axis, which for my use case and the size of the bed isn't too bad. I then added some 3D printed brackets for a removable side panel, which simply rests on these two parts and is held at the top with some magnets. And for the front panel, I decided to go with a 4mm sheet of polycarbonate, which is again held on with 3D printed hinges. I will eventually add a handle and probably some magnets to hold the door closed, but that's a job for another day. I then found these plastic strips on AliExpress that are designed to fit in the extrusion gaps, which is perfect for preventing cutting chips from collecting, as there are a lot of exposed slots. And I also printed these flexible TPU covers for the homing limit switches, in case they get covered in metal chips. And also added a much needed emergency stop button to the front of the machine for the almost guaranteed surprise mistakes. To control the CNC, it requires a network to use the web control. So I bought a cheap touchscreen monitor that can be plugged into a low-spec PC that I found on Facebook Marketplace, as it only needs to run a single Google Chrome tab. And while this does work for controlling and monitoring the CNC, it's not ideal. Fortunately, it's possible to add a CNC pendant with a jog wheel to the Duet controller. So I bought this off AliExpress for £32 and followed the instructions on the Duet website about connecting it with an Arduino board to communicate with the Duet mainboard. And now I can control all 3 axes using this jog wheel. Now all it needs is the spindle to be wired up and programmed, and we should be able to get cutting. Just one small tip, don't leave a loose collet nut on the spindle when first spinning it up, especially if the spindle spins the wrong way. For the first cut, I decided to go with the classic tape and superglue fixturing method, as I haven't cut any fixturing holes in the cutting bed yet. So I stuck down a small sheet of MDF and zeroed in the workpiece using the jog wheel, which saves so much time. This first cut is very basic with just a few square and circle cutouts, as I want to check everything is working before cutting aluminium. Also, the finished quality isn't that great, mostly because I'm using an up spiral bit on MDF, but also because I think I used my aluminium speeds and feeds on this. But after a light sanding to remove the edge roughness, it turned out alright. The next step is to turn the cutting bed into a fixture plate, which requires drilling, counterboring and threading 178 holes. So before I potentially ruin the expensive build plate, I stuck down a spare piece of aluminium and attempted to drill a 6mm hole, which was never going to work well. Firstly because the spindle doesn't have enough low RPM torque, and also because the drill bit won't go further into the collet, so it's really long, which causes it to flex. It did make it all the way through in the end, but it's definitely not ideal. I then used a 4mm end mill to counterbore the hole to 10mm, so it will allow shoulder bolts or dowels to be used for indexing parts. And then finally finished off the hole with a thread end mill, which is an awesome tool for this CNC, as it has these thread-shaped teeth that cut a perfect M8 thread by spiraling up the previously drilled hole. And this counterbore and thread can be used for both bolts and dowels, or a combination of the two by using shoulder bolts. So now this just needs to be repeated 178 more times in a 200-pound plate of aluminium. However, there is an issue with the Z-axis travel. At its lowest point, the 4mm end mill needs to stick out a long way in order to cut all the way through the bed, which is why I was testing out the 6mm drill bit earlier. But seeing as that didn't go very well, my next best option is to lower the spindle. This isn't ideal as the spindle collet is now able to crash into the bed, but as soon as the fixture plate is done, I'll move it back up. So here we go with the first toolpath drilling 178 holes all the way through a 20mm aluminium plate, which was quite nerve-wracking considering it's only the third cut on this machine. However, to make sure everything was going well, I programmed the G-code to drill the holes in 4 operations. So every 44 or so holes it would stop so I could clean away the chips and check nothing was overheating or loosening. Fortunately it all went to plan and it's now on to the next toolpath, which is counterboring all the holes. In hindsight, because the counterbore is only 6mm deep, I probably should have moved the end mill upwards into the collet to reduce flexing, as this affects the inside surface quality of the hole, but the plate will still work just fine as it's nothing too serious. So after all the holes are successfully counterbored, the penultimate toolpath is to thread the holes, which honestly I've never been happier to find that thread mills exist, because tapping all 178 holes by hand would be near impossible, at least within the time frame that this tool could do it in, as it's cutting 14mm deep M8 threads in about 20 seconds, which would get extremely tiring to do with a handheld tap. And now the fixture plate is essentially done, but I thought it was missing something, so decided to chamfer all the holes. This was by far the quickest toolpath, and although it doesn't really add any purpose, it does make the fixture plate look far more professional. So now let's try making something. I don't currently have a milling vise, so have to use the next best thing, my drilling vise. Which I know you machinists out there will be fuming, and yes, it does cause issues later on. But until my milling vise arrives, this will have to do. But at least it clamps well to the fixture plate, and it has to be better than the tape and glue method. I then zeroed in the workpiece using the jog pendant by simply touching the end mill up to the surface, which works well, but I might purchase a probe in the future to make this easier and faster. The part I want to make here is a basic rectangular block, which will be the first upgrade for this CNC machine, as the current Y-axis lead screw is transferring all of its force through 4 25mm standoffs, which isn't ideal for rigidity, so this block will replace the standoffs. I started by boring the holes with the same 4mm end mill that I used to do the fixture plate. However, this time it was going through 25mm stock rather than 20mm, which didn't end well. Fortunately, these are cheap end mills, so I replaced it and only bored the holes part way through the stock, so I can later drill them by hand. The next operation is to face the top of the block, as it's currently 25.5mm thick, so taking 0.25mm off the top and eventually the bottom will make it the perfect size. I don't currently have a method of applying lubricant and coolant to the part, so I just spray on some WD-40 every so often, which should do the job for now. The final operation of this top half is to cut the outer shape of the block, which it seemed to cut okay, but again because of the depth of the block, the 4mm end mill has to stick out the collet quite a way. So there is a lot of flex and therefore the surface finish isn't great. Also, the back face of the block doesn't allow for much chip evacuation, as it's essentially a slot, so the end mill struggles a bit. Once removed from the machine, the block is held onto the stock by 3 tabs, which I can cut off using a hacksaw, and then place back in the vise to machine the bottom side. And because it doesn't need to cut the full 25mm depth, I also shorten the length of the end mill, which seemed to improve the surface finish a lot. At least on this face, because I hadn't zeroed in the part properly, so it was barely cutting any material off the side face. After facing the bottom surface, I then finish off the part with some chamfered edges, and the part is somewhat done, albeit not that impressive. But hey, I'm an engineer, not a machinist. So let's start again and think like a machinist. The key to a good part seems to be rigidity, so I swapped out the 4mm end mill for a 6mm end mill and surfaced the top face. Then for the other faces, I only faced the front and sides, leaving the slot and tabs for later, hopefully holding the part as rigid as possible. And this surface finish is looking far better. I still went down to the full 25mm depth in one operation to prevent having to perfectly zero the side faces once the part is flipped. And then once the 3 faces are done, I could then cut the slot which will separate the part from the stock. However, I set it to leave a small amount of material for a finishing pass once the part is flipped. The machine still needs some tuning, but I couldn't be happier with these early results. That surface finish is a completely different level compared to my old CNC router, and seeing an almost mirror finish on a machine that I designed and built myself is so satisfying. I then cut off the stock with a hacksaw and mounted the block back in the drill vise to machine off the tabs, which didn't quite go to plan, and made me realise why you should never use a drill vise for milling. The reason why this happened is when the vise clamps down on the part, the force from the screw is applied to the middle of the vise jaws, but the part needs to be on the edge to machine this face. So the vise jaws twist and end up only gripping the part at a very small point on this corner. To prevent this, I used the old block that I machined earlier to stick in the other side of the vise, which helped keep the jaws somewhat square, and we can continue with the machining. I was a little worried that the mistake had ruined the corner of this part, but there is still a lot of material to be removed from this face. In fact, a little too much. But at least I know the rigidity limits of this machine, assuming it's not just the end mill flexing or chips getting in the way. So I finished off the operation with multiple depth passes, like I did on the other 3 faces, to hopefully recover the surface finish. And then face the top of the part at 0.25mm depth to make sure the part will eventually be 25mm tall. I then rotated and centered the part in the vise, as it doesn't require any more machining on the side faces, and bored the holes part way through, which act as a guide for manually drilling the holes on my drill press. Then it's back into the CNC for finishing the part with some chamfered edges. So the first few parts turned out alright, at least once I figured out how to machine properly. I've still got lots of learning to do on this machine because I've only operated a very basic CNC machine in the past, cutting out 2D shapes. So doing finishing paths and facing paths and chamfers is all new to me, so there's lots to learn there. I do finally have my new milling vise, which is quite heavy, but I need to figure out exactly how I'm going to mount it to the fixture bed because it only has these slots on the side here. So I've been 3D printing some prototype clamps to use. Once I'm happy with the design of the 3D printed clamp, I'll obviously machine some metal clamps which will be far stronger. I also need to figure out a solution for preventing metal chips landing on these rails and the ball screw, as well as falling through the centre of the frame. I've currently just taped some plastic bags underneath here just to prevent the chips landing on the floor. But I'll probably use some sort of brush system. I've got these long brushes so that the axis can still move but chips won't be able to fall through. It's just very difficult to design because it's a very small space to work with, but that's something to sort out in the future. I've also bought a very small probe which I can stick in the collet of the spindle, which should make it easier and more precise to zero in the workpiece. It's possible to do it with the end mill, but I need a bit more practice because I got it wrong on that first part. I think just take my time a bit more and using the CNC pendant, a bit of practice with that, I should get it pretty close. But this will just make it far quicker, far more precise, hopefully. Speaking of the CNC pendant, I absolutely love this thing. Just being able to control it. There's a bit of a delay because the axis doesn't move that quick compared to the, compared to me spinning this. But it's also got 3 increments, so I can do 1mm movement. So you can probably see that move. Or there's 0.1mm movement, which you probably can't see that move. And then there's 0.01mm movement, which is, I don't know if you can even see the thing spinning. But if I wind this, every rotation of this is 0.1 of a millimeter. So 0.1, 0.1, 0.1. So yeah, you can get some pretty precise movements with this, which is very nice. Much easier than using the screen, which is currently disconnected for some reason, which is why this is far better. But yeah, that's pretty much it for part 5 of the CNC build. Hopefully I'll have another video out when I have this vise fully clamped down and we can make some more precise square parts rather than using my drill vise, which was just a bit of a nightmare, to be honest. Thank you very much for watching, and I'll see you in the next one. Bye.